Welcome to the first episode of our Aviation podcast. Today we are diving into the fundamental principles of aerodynamics, specifically the forces acting on aircraft, glide performance, climb and descent rates, and key aerodynamic concepts like the aerofoil, engine of attack, and wing configurations. Every aircraft in flight is subject to four main forces: lift, the force that opposes weight and allows an aircraft to stay airborne; weight, gravity, the force pulling the aircraft toward the earth; thrust, the force generated by engines or propellers to propel the aircraft forward; drag, the resistance, force opposing forward motion. When the thrust and drag are in balance, the aircraft maintains a steady speed. To accelerate, thrust must exceed drag. Similarly, when lift equals weight, the aircraft remains at a constant altitude. To climb, lift must exceed weight. In a bank turn, weight remains constant, but effective lift is reduced due to the loss of vertical component. To maintain altitude, pilot must increase speed or adjust the angle of attack to compensate. The aircraft achieves its maximum glide range when it's flown at the optimal lift-to-drag ratio. This occurs at a specific minimum drag speed, VIMD, and angle of attack. Surprisingly, weight does not affect glide range if the aircraft maintains the correct speed and angle of attack for its weight. A heavier aircraft glides the same distance as a lighter one but a higher airspeed, meaning it reaches the ground more quickly. The rate of climb or descent refers to the vertical speed of the aircraft, typically measured in feet per minute (fpm). A higher rate of climb means the aircraft ascends faster, while a higher rate of descent means it descends more quickly. A heavier aircraft has a greater rate of descent because it must fly at higher airspeed for the same angle of attack. This results in a faster downward trajectory. An aerofoil is a structure designed to generate lift efficiently. Examples include aircraft wings, tailplanes, rudders, propellers. Key aerofoil terms: chord line, the straight line from the leading edge to the trailing edge; mean chord line, the average chord length across the wingspan; mean chamber line, the line equidistant between the upper and lower aerofoil surfaces; angle of incidence, the fixed angle between the aerofoil's chord line and the aircraft's longitudinal reference line; angle of attack, the angle between the chord line and the oncoming airflow. Adjusting this angle affects lift and drag. A washout is a design feature where the angle of incidence decreases from the wing root to the tip. This prevents premature wingtip stall, enhancing stability. Dihedral, wings angle upward from root to tip, increasing roll stability. Antihedral, wings angled downward, providing greater maneuverability to reducing stability. Understanding these aerodynamic principles is crucial for pilots and aviation enthusiasts. Stay tuned for our next episode where we'll be explored lift and its role in flight. Thanks for listening and happy flying.